Density is another important glass characteristic. And we're going to talk a little bit about density, as this is a science class. We're going to spend some time talking about density and how to measure it. So the definition of density is a substance's mass per unit volume. So how much stuff is there in a given amount of space? And when we say how much stuff, we would measure that in science by measuring the mass of that substance. And how much volume, how much space it is would be its volume. So we have ways we can measure mass. That's pretty easy. We put it on a scale. And we have ways we can measure volume. And we'll talk about a couple of ways of that. And from that, I can calculate the density. We also have some direct density measurements we'll discuss. So remember, if I have an equal size volume, it's pretty easy to tell if it's the same substance, which one is more dense and which one's less dense. So in this particular one, the first one, I have these equal size volumes. And one has 1, 2, 3, 4, 5, 6, 7, 8 balls in it, and the other one has many more. If those balls were made of the same substance, like they each had the same amount of mass, then I can see the one on the right is more dense. There's more of them in there. But if I have different substances, like in the bottom one, I have styrofoam and I have some brass, it looks like brass beads. We know from having held styrofoam and having held brass beads that they're not the same density. But just looking at how many are in a given space, I just can't tell the density. I would have to sort of compare them. Now, if they were the equal handfuls, equal volumes, then I can say the one that is more heavy is the one that is more dense. So we kind of know from experience that styrofoam is fairly light. Now, again, light does not mean that it's density. I could buy 40 pounds of styrofoam, and that's no longer light anymore. It's now heavy. But it's about how light or heavy it is for a given amount of space. So for the same amount of substance, the same volume of substance, a handful, the styrofoam is significantly lighter, thus it is less dense. Now, one way we can measure density is what we call the displacement method. So I can measure the mass of an object. If I have a specific object or even a sample of some stuff, I can measure the mass by putting it on a scale. That's pretty easy. The harder part is how to measure volume. We did do volume calculations when you're in math class and geometry class in high school, but that turns out to have a lot of limitations to it. Another way we can measure volume is that we can use what we call water displacement. If I put an object that will sink in water into water, it's going to make the water move up or displace. So I take a graduated cylinder, so I know how much water I have at the beginning. I fill it with some water, and I see how much volume there is, and I record that. Then I take my object that I want to know the volume of. I put it carefully into that graduated cylinder of water, and the water level is going to rise, right? And then I measure what is its new volume. It turns out that the change in the volume, how much the volume rose by, is the volume of the object. The reason it rose is because the object was taking up the space where water previously was, and it pushes the water up. So I can take the final volume minus the initial volume, get the volume. Once I have that answer, I can take the mass divided by the volume. I can do it in one step as well. It turns out this method is great for science classes and for teaching the concept. It's not going to really be precise enough. There's some issues with it. So the precision of the volume measurements on the graduated cylinder is an issue. I can have splashing. I can have air bubbles. If the object has any hollow spots inside, that's going to kind of confuse things. I'm not going to get a good volume of the true volume of the stuff. So this is not perfect, but it's great for asking questions in a science class. Another method that we're going to try in class is the flotation method. So it's a much more precise method. It can be rapid if you kind of know what you're doing. Again, if an object is less dense, it's going to float. If it's more dense, it's going to sink. When it's the same density, it remains suspended. So in this flotation method, we keep changing the liquid. So I want to measure the density of glass. I put the glass in some liquid, and then I want to keep changing the liquid to different densities. Once I match the density of the liquid to the density of the glass, that glass will remain suspended. So I will adjust that, and at that point, once I have it where it's suspended in the middle, now I know I have a density match. I can measure the mass of the liquid pretty easily, and then say, so that's the same mass as the same density as the glass. Just to kind of back up a bit on that. So this idea of floating and sinking is a big concept, and it's related to density. It's also related to buoyancy force, and that's a much more complicated physics problem. But we can say it's basically going to be related to the density. If the two things I'm mixing don't dissolve. So in other words, when I put sugar in water, this doesn't work because the sugar will mix with the water. But if I put glass in water, glass is not going to dissolve in water. And so in that case, the glass is probably more dense than the water and would sink to the bottom. If I put it in a different substance where the liquid was more dense than the glass would float. So we see like here, this cork is not very dense. In fact, it's less dense than the oil, so it's floating. Whereas this plastic block is more dense than the oil, so it's sinking in the oil. But compared to the water, the plastic is less dense than the water. And I'd have to choose in these particular syrup and water and oil have to be substances that they themselves don't mix to get this. So this is kind of a rough way I could kind of measure different substances. All of these are floating and sinking. I'm not showing when we have a density match and you see it submersed, but if it's submersed, it would be like literally hanging out. Wherever you put it, it would stay. So if you were to kind of put it into the middle of that liquid layer, it would just hang out there. So in this particular case, we look at this grape. I see that the grape is sinking in the water layer. So that means it is more dense than the water layer. And it turns out water's density is about 1. And it is floating in the syrup. So the pancake syrup has a density about 1.3 to 1.4. They'll quote it as 1.37, but it really depends on the specific manufacturer, etc. So I know that this grape, I now have boundaried it. It is somewhere between 1 and 1.37 in density, grams per milliliter in density. So I can measure things using this method. That's the concept we're going to use in this submersion method or flotation method. So this is how it's done professionally. If I needed to determine it, I can basically mix two substances of known densities, and I have to measure them out as I'm changing the density mixture, because what we'll be doing in class is I start with the heavier one in there, put the glass in, the glass is going to float. And then I add in drops of the lighter density mixture, and I stir them. And as I get it where there's an exact match, I now will have the glass piece will suspend. And when that happens, I can do some calculations. I can basically find from how much I used of the heavy density times the density, how many I used of the light density times its density, divided by the total number of drops. I can calculate the density of that mixture that I made. So this would be one example of how we're going to do it. So we will do something like this in class. I'll use the bromoform. It's kind of nasty stuff. But we'll do some with some not glass pieces and some ethanol and water, so we get the idea of how this density method works.